The 5G energy gap. Brian, just what the heck is that?
So the 5G energy gap is really just more of an awareness of the growing exponential gap that will come from the predicted growth of the many, tens of billions, or you could even argue a trillion devices that are to be on the network in the near future. When you hear about the deployment of 5G and all the hype around it and the millisecond latency and the gigabit bandwidth, usually all the attention, excitement and stuff is around all these, streaming, VR, AR, industrial automation, autonomous vehicles and all these high bandwidth type of things that run off a wireless network now. And when I did a little napkin math and I realized that just how much you pay for power, the further you get from the source. So in other words, the closer you get to the edge, the further you are from the power plant, where that, in most cases, that energy has to be generated. And what I realized is that when you get to the point, especially of wireless devices, that you can be paying upwards of 5 to 6 orders of magnitude of a power cost factor through the entire, what I call the power value chain, which is from the load where it's ultimately used all the way back up to the power plant. When you look at it from that perspective, you may say that, all these micro power devices, most of them are relatively dumb from a bandwidth perspective. They're low bandwidth, high latency things, but they're the things that are going to scale in numbers. If there's going to be a trillion things out there, over 95% of them are going to be these little tiny power devices. But because of that and the scale of that, you can have many in a localized area. So, and the reason it doesn't apply to things like smartphones or other, your smart fridge or whatever like that is because you won't put 10,000 of those in one localized little space or serviced by one, whatever base station or router or whatever you want to call it. But the scale for the potential of the micro power device, if I have embedded ubiquitous sensors, I can have 10,000 of those in this building. And so that's where at least the call to action is from my perspective, is that people need to be doing this analysis from the end-to-end network perspective with that in mind. Because if you, I hope I'm wrong, but I hypothesize that, scaling all these tiny power devices could, at the very least cause some grid instability, and at the worst case cause, massive blackouts and failures and things. And everyone is happily deploying this 5G network just as fast as they can now. And I don't think there's much consideration for what I'm talking about. So the whole point of that article was really to kind of stir the pot and have people either tell me I'm super wrong, which honestly I hope to be, or that, maybe we should look at it. And to me, that's the win. If they're at least looking at it and raising the question, then that was the real goal. And, and at the end of the day, anything that brings more focus and resource, especially to large players in the industry, to energy efficiency and improved, power utilization in devices and systems is a huge win for all of us.
Well, and you bring credibility to it because you are a power supply designer, I suppose, right?
Yeah. At least in a former life and somewhat to today. But I kind of say I'm a soup to nuts power guy, where I started my career in the data center side of things, doing server power for folks like HP and Cisco. But I also worked for Emerson Network Power and have been on the, kind of the business side of thing and technical sales and marketing support, and spent a lot of time in factories and also the global logistics side of things. So when I started my independent consulting business, I said, I always had kind of an interest and passion in energy harvesting and this ultra low power stuff that I started to research and cultivate more. And then this 5G thing came along and I said, I don't know anything about, cellular networks or telco power aside from data center stuff. I said, but my gut tells me that just based on the high level specs, that the way you architect, distribute and utilize energy for this network has to be something very different. And that's when I started to research it, and then I was asked to give talks on it, and that's where I realized the kind of now the culmination of all that is where the 5G, IoT, and all and their massive deployment come together to have this potential issue, the 5G energy gap. But now this other area, which was just kind of a cute emerging technology area that I focused on, energy harvesting, well, now it suddenly has a real purpose, because now supplementing each microwatt at the edge has a multiplicative value that's, 5 plus 6 orders of magnitude.
And it's amazing. You showed multiple examples, this watch being one of them, of the various energy harvesting ways that are working today, right?
Yeah, absolutely. In the 6 years that I've been trying to evangelize energy harvesting technologies and kind of help bring it to the mainstream and bring the ecosystem together and connect the supply chain with the user and application side, nothing makes a better demo or more effective one than a tangible thing or something. It's one thing to show pictures on a presentation, or even to show an eval board or something, but something that looks like a real consumer product, a smart watch. And granted, especially a first generation one, it doesn't have all the bells and whistles of something, and frankly, this particular doesn't even necessarily always operate that well, but it's a start, and it shows that something that so that people can look and feel and relate to. And that's kind of the same thing like with this kit, that this whole development kit that Verth and Linear put out, it's just enabling because it's a one-stop shop. It has everything you need, from the transducers to the power management circuits, the energy stores, the networking stuff, a display, and that's what's enabling to people, to engineers, that once they're convinced on paper it's interesting and worth looking at. You also have to tell them that they don't have to completely reinvent themselves or learn many new skills just to be able to want to test it and play with it on their bench. So that's where something like this kit is just right out of the box. They can focus on their application and the viability of energy harvesting technologies for their need, without having to learn an area.
So I want to go back one moment to the 5G. You mentioned there's an initiative that you're involved with.
Yeah, it's through the IEEE. They have what they call the Future Networks Initiative. It actually was previously the 5G Initiative, and they rebranded it. And there's a couple things I'm involved with. For one, they have a webinar series, a 5G webinar series, which I co-chair, and we try and have a monthly webinar, which is free, open to the public. And then also they have a roadmap effort, INGR, and I got involved with that. There was an apps and services group, which was kind of a catch-all, which is where stuff about energy efficiency went. And the more I went along and connected to this whole 5G energy gap thing, I said, look, this story is way too big and too important to just be a paragraph or two buried in this chapter that's kind of a catch-all for stuff that didn't fit neatly into other chapters. And so it convinced them to generate a whole energy efficiency working group, which, of course, by suggesting it means I now co-chair it, along with my colleague Francesco Carabolante of IoTissimo. So what we're doing is since the first edition roadmap just released and we just started this working group, we're initially starting with a white paper that is actually being written right now. We actually have our first team kind of working group kickoff meeting this Friday. And the idea is that white paper will be going out soon, which follows up on a position paper that was put out last year or the year before. And then eventually, probably in about a year's time frame or so, it will graduate to a full roadmap chapter completely focused around energy efficiency and many of the concepts that we've talked about tonight, as well as expanding on a lot more.
Well, excellent, Brian. I appreciate your tutorial on energy harvesting and tonight that you gave, and for this talk. So
all right. Well, thank you, Ken. Appreciate it.